Hello, welcome to an introduction to Passivhaus. My name is Ken Levenson, and I'm the Executive Director of the North American Passivhaus Network, or NAPHN. Thank you for joining this presentation. I hope it leaves you thinking differently about buildings and ready to act. NAPHN is a national nonprofit organization that educates and builds peer-to-peer knowledge sharing networks across the U.S. We have 6 chapters currently, 5 regional and a 6th that is a catch-all chapter, coast to coast, Passivhaus America. We work in support of professionals working with the International Passivhaus Standard, and we are affiliated with the Passivhaus Institute and the International Passivhaus Association based in Darmstadt, Germany. We connect global knowledge, regional contexts, and the needs of local applications. We connect you to others across the US and around the world. Our members include students, architects, engineers, builders, developers, real estate professionals, policymakers, and many more, all engaged in the transformation of our built environment. We encourage you to join the effort. Join us as a member. We need you. As we start, we want to thank our partners, sponsors, and supporters, without whose help we couldn't provide these presentations. If your company works in the Passivhaus space, we encourage you to support us and make a more robust connection to this important and fast-growing segment of the U.S. building industry. And we want to encourage everyone to get Passivhaus training and education because, as you'll see, Passivhaus education really does change the way you think about buildings and work on buildings. This short introduction is a good start, but just a start. Step 1 is often the one-day introduction to Passivhaus, which gives a more comprehensive and quite a detailed look at Passivhaus, including fascinating real-world case studies. And it is appropriate for anyone interested in the subject or who works closely but tangentially with Passivhaus. And if you work directly on Passivhaus projects, you should definitely complete one of the core certification courses, either the designer course or the tradesperson course, which is geared specifically to construction crews. And then depending on your work focus on Passivhaus projects, there are a great variety of specialized courses you should take. And we are going to be offering a wide range of these specialized courses as 2021 progresses. And finally, before we start the presentation, I want to mention NAPHN's 2021 Passivhaus Conference, June 10th and 11th. It's themed with the call to action, Passivhaus for All, to be more accessible and inclusive. It will be a hybrid conference, in person in New York City and online, so that everyone who wants to participate can, where they are most comfortable. It should be fantastic, so stay tuned. So let's begin. Today, we face interrelated and interlocking crises, environmental, health, and social crises. And while how we deal with them or not is an individual choice, we all should be able to recognize the power of buildings to help solve our problems or to exacerbate them. As the Reverend Mariama White Hammond of the Green Justice Coalition and others have said, building is not a neutral act. Passivhaus alone is not the solution to anything, of course, but it can be part of the solution. What's different with Passivhaus is that it uniquely recognizes and embraces the power buildings possess, what the architectural structure holds, and empowers architectural solutions to fundamental problems. We must eliminate carbon emissions, and with Passivhaus, the architecture itself can drive energy efficiency. We must protect health. Passivhaus places hygienic indoor environments as part of its foundational concept. We must provide storm resilience, and Passivhaus provides the most robust shelter-in-place potential possible. We must provide affordability. This cannot be for the 1% or the 10%, but for all people. Passivhaus provides affordability both in initial costs and in long-term operation and maintenance. And in these uncertain times, we need to mitigate future risks to our investments, whether it's a down payment on our first modest home or an organization funding big commercial building projects. Buildings are huge investments, typically our biggest investments. Today, with fast-changing environmental and regulatory conditions, these investments face an increasingly uncertain future. How do you lower your risks? Build a Passivhaus. Passivhaus cuts through the twists and turns and gets you over the horizon to the goal line. We're headed to a zero carbon future. With Passivhaus, we can build to meet that future today. With Passivhaus, you can future-proof your buildings. A goal of this short presentation is for you to better understand what this all means and how it's all possible. Understand how you can utilize Passivhaus to make the change you want to see in the world. We hope you'll never be able to look at buildings the same way again. So let's first take a step back. What came before Passivhaus? What's the prehistory? Of course, Passivhaus didn't spring out of nowhere. It was formulated based on a long history of efforts. Not surprisingly, like so much received wisdom, it starts with vernacular architecture. And the example of southern China is of particular relevance because it was the study of the performance of these buildings that helped inform the work of Bo Adamson, a Swedish academic, launching the Passivhaus idea for a research project in Europe. Another interesting example is the Norwegian polar explorer ship, the Fram, which contained all the principal strategies of Passivhaus building, with fresh air and the occupants' comfort provided by only a single lamp burning. In Denmark, the DTH Zero Energy House provided valuable experiences directly incorporated into the start of Passivhaus research. In Germany, a super-insulated experimental home showed the potential of passive measures providing energy savings on the order of 10 to 20 times in Europe and America. And in the United States and Canada, pioneers like Wayne Schick, William Shercliffe, Amory Lovins, Harold Orr, and others pushed super-insulated developments in the 70s and 80s. These and many more examples were the precursors of the birth of the modern Passivhaus. We should note here, as a clarification sidebar of sorts, that none of these precedents were what we'd call passive solar buildings per se that proliferated in the 1970s. These precedents are not overglazed and rely more on a balance achieved with super insulation. It's understandable that people mistakenly draw a direct connection between passive solar and Passivhaus because of the similarity in name and use of passive solar heat gains, but the connection causes endless confusion and wrong-headed assumptions. Personally, I'd compare it to someone confusing an electric golf cart for a Tesla automobile. They have their similarities, but occupy different realms of development and considerations. So, the first Passivhaus was built in 1990 as a research project, a physics experiment in Darmstadt, Germany, by an international team led by Dr. Wolfgang Feist, the founder of the Passivhaus Institute, and included Bo Adamson and many others. It was and is composed of 4 attached row houses, complete with custom building components developed for the experiment. And this research solidified the underlying principles and strategies that would become the Passivhaus Standard. The story goes that Amory Lovins visited the building and provided the insight that these new developments could be standardized and scaled to great effect on the building industry. And from that time, the Passivhaus Institute has continuously conducted research and developed tools, working with industry and government partners worldwide to make Passivhaus buildings the new normal. So what changed? What was the discovery of this Passivhaus experiment? What flipped in our thinking? What came out of this research was the essential power of the Passivhaus concept, that despite our focus on energy efficiency and seeing comfort and health as a result of efficiency as side benefits, it is instead the focus on occupant comfort and health that drives performance. It starts with the occupant. Per the purely functional, shall we say Platonic or idealized definition as it was distilled, we quote, "A Passivhaus is a building for which thermal comfort can be achieved solely by post-heating or post-cooling of the fresh air mass, which is required to achieve sufficient indoor air quality conditions without the need for additional recirculation of air. This describes maintaining comfort and health with 100% fresh air with a very low capacity for heating and cooling energy. You need a very energy efficient building to achieve this. Consequently, health, comfort, and efficiency are all working in the same direction, all supporting each other. So we have what's really a comfort and health standard producing an energy standard, the Passivhaus Standard." This diagram shows homes, but it could be any type of building, with heat losses below the middle line of equilibrium and gains above the line. We could also flip this to be about cooling in a hot climate. In the old, very leaky and modern, moderately leaky, shall we say, homes, large active heating systems are required to bring the building into balance, as the gains above must equal the losses below, while the passive house building requires a tiny fraction of the energy to be brought into balance. This dramatic reduction in heating and cooling demand demonstrates the power of the optimized passive architectural structure and will flip our expectations. It's a flip that we've experienced with our computer industry, where computers get ever more powerful while using much less energy. And so too, Passive House decouples power from performance. Passive House provides a clear pathway to decouple and frees us to deliver zero carbon buildings today. This is game changing. Let's look at what Passive House delivers. The Passive House concept starts with the occupant, as we've said, and moves outward. What makes us comfortable? Well, how about steady temperatures? No drafts, no cold feet, peace and quiet. How about sitting by the window on a cold winter day and feeling comfortable? Passive House provides hygienic indoor air quality, 100% fresh air and exhaust with no recirculation. It's filtered fresh air, keeping pollution out. No mold and associated illnesses, reduced asthma and allergies. Passive House provides resilience that we can shelter in place indefinitely in winter and in the summer for an extended period, long enough for the power company to get things up and running again. This example is from a home in Brooklyn, New York, several polar vortexes ago. The black line is the exterior temperature diving down and staying freezing for 4 days. The red line is the interior temperature. Not a flat line, but steady, and we see the one moment when the family turned on the heat during the week. Passive House supports equity by delivering high quality, comfortable, and healthy homes that cost dramatically less to operate. The dramatic reduction in energy usage also protects people from possible future energy price shocks. This is an affordable housing development for seniors in Queens, New York, that also has a pre-K school on the ground floor. Passive House first scaled in Europe with affordable housing projects. And today, in the US, we see affordable housing advocates incentivizing and encouraging Passive House building. Passive House supports our country's transition to a green grid and electrified future. The dramatic energy reduction of Passive House makes removing fossil fuels from buildings economical. And with renewable energy options available on-site and off-site, Passive House makes grid utilization more efficient and resilient. Consequently, the more passive houses we build, less renewable production is ultimately needed, making our green transition more affordable and quickly achievable. To achieve these results, Passive House doesn't look to more power first to solve problems. Instead, as designers and builders, we re-engage the passive building elements, the architecture, the structure itself, and empower it to do the heavy lifting. As you would first place the fulcrum of a lever in the optimal position to lift a weight before applying power to actually lift it, in our case, the enclosure is the fulcrum. And how we formulate the enclosure, like the placement of the fulcrum, has an equally profound effect on the power needed to provide comfort and health. This flips our business as usual thinking. Passive House asks us to question everything, to effectively restart, like going back to the ancients, going back to school. How do we optimize and empower the passive building elements to do this heavy lifting? And this goal, this quest of unlocking the power of the passive building structure re-engages our focus with the ingredients, the recipes, the materials, the details, and the craft of building. It empowers and energizes the project team, from the owners to the designers to engineers, architects, builders, construction site laborers alike. Nothing is taken for granted. And this quest for passive building power has us designing and building with the energy flows and the energy balance, not as far off abstract concepts, but instead as active tools that inform everyone's work. The question becomes, do we have the imagination? Do you have the imagination it takes? Don't be deceived by what you may or may not think is possible. Passive House is just starting, and like the stone master builders of medieval times, Who could have imagined that working in stone, they could develop the flying buttress? They could effectively dematerialize the walls. It was an astonishing transformation, perhaps unimaginable. Today, Passive House is evolving rapidly. So let's move the frame of reference. Let's look at towers and shake our preconceptions about what is a Passive House building and what might be possible. Here we have, from left to right, a bank headquarters in Vienna, then a midtown Manhattan high-rise, mixed affordable and market-rate apartment building, a 60-story residential tower starting construction in Vancouver, and on the right, a mixed-use high-rise under development in Boston. Not your typical Passive House buildings. And even more so, here's a garment factory in Sri Lanka, Passive House certified. And of course, there is housing. This is an affordable housing development in Norwich in the United Kingdom that won the Royal Institute of British Architects' highest award, the Sterling Prize. So here we have affordability, performance, and architectural design that is recognized, all in one package. So with these few examples, I hope we can shake off any of our residual self-imposed artificial limits on what might be possible. But beyond imagination, we should also address upfront the very real and concrete concerns about cost. After all, it has to be affordable to be successful. And here we have to change our thinking too. Passive House is not an ad alternate in the bidding process. If you do that, it will fail. Passive House can't be considered an upgrade. This too will doom it in the project. Instead, Passive House must be a fully integrated approach and goal. It is the only way for it to succeed. And it is not the cheapest either. This is high quality construction, for goodness sakes. But it's affordable high quality. And as a fully integrated goal, experience shows us that the Passive House related decisions can actually drive down costs as much as they might raise costs. In fact, there are so many other decisions in a given project that have a much greater impact on the ultimate project cost. Passive House shouldn't be breaking the budget. Passive House should fit in your budget. Let's note this graph that demonstrates the lack of direct correlation between passive houses, the blue dots, and non-passive houses, the black dots, and cost. In these examples, Passive House was not an add-on, but an integrated goal, and it shows the average cost of the passive houses to be less expensive. I don't know all the decisions made, but clearly optimization in the designs and construction are driving affordability. However, let's not count on it being cheaper. After all, we don't eat as nutritiously as we should, and we don't exercise enough either, at least most of us. So let's not assume we're going to optimize our passive house enough. It's life, right? So let's aim for affordable, not the cheapest, maybe even a little bit more. And what we're seeing is that a 3 to 5% increase in project cost from a reasonable baseline can be expected. If the increase is greater than 5%, then the decisions need to be re-examined. Something went off the rails in the process. So let's say a few brief words on staying on budget. Passive House must be included at the very conception of your project. You really must work with your Passive House building certifier from the beginning and benefit from their institutional knowledge. Don't dig a hole on day one that you have to then get yourself out of. Require the team of professionals and builders to have proper Passive House training. Optimize from the start and stick to getting certified. Stick to the target. And if team members are feeling like something is just too tough or seems impossible, it could be that a lack of experience and known references is inhibiting them. Get them to reach out. Find examples and experiences around the world. They are out there. Because while Passive House is young, there is a world of experience to benefit from. The global Passive House community is generous in sharing information. Use that. We can't be islands and succeed. And let's be clear. If you are diligent and you eat your spinach and you run those laps, you can come in at cost or even be less expensive. But easier said than done, right? It may seem impossible on its face. I mean, how can you be at cost parity or close to cost parity and have all these amazing benefits? Predictability is the key. You can fully optimize the performance and the economics if you have a strong sense of predictability. if you can calculate accurately and execute to a clear plan. So the Passivhaus Institute didn't just give us this new concept and say, hey, go do it, good luck. But instead, it provides a pathway, a methodology, and a wide and growing number of tools to enable predictability. Building certification is critical, but there's much more to it. There are component certifications of essential components like windows and ventilation units. Be sure to check out the database of thousands of certified components on the Institute's website. And critical personnel certifications on the design and construction side. The PHPP energy model is an active tool in the design of the building. Reference materials abound from the Passipedia, the building database, and other corners of PHI's vast website. And PHI conducts ongoing cutting-edge research around the world with new uses, new climates, new typologies, and new methodologies. The Passivhaus Institute has over 60 employees from all over the world, many of them not just building scientists, engineers, or architects, but physicists. It's an extraordinary brain trust that you have the opportunity to work with. And the knowledge is widely shared through many channels, including the International Passivhaus Association, of which NAPHN is a part. Your membership in NAPHN makes you also a member of the International Passivhaus Association. The peer-to-peer global knowledge sharing network may be the most powerful aspect of all. It is also possible because the pathway includes very clear certification targets with metrics that include comfort, health, and energy. These are not relative targets set to a baseline that can be gamed, but hard targets that leave you knowing where you stand. Today, the targets include increasing levels of renewable energy production integration and greater efficiencies, buildings built to be future-proof. The certifications also extend to retrofits with the NAPHN standard, also including higher levels of performance and renewable energy integration. NAPHN provides flexible pathways, including a step-by-step strategy that allows for phasing of work in sync with the replacement cycles of the building systems, ensuring the Passivhaus performance is the end result. We mentioned the building certifiers earlier in relation to controlling costs, and the importance of their role cannot be overstated. We are fortunate to have 12 independent certifiers operating in the United States today. They work cooperatively, sharing experiences and information with each other, and the certification process from day one of your project is critical to making success normal. And a side note, but an important one. We see today more and more buildings claiming to be Passivhaus buildings, or they're advertised as being built using Passivhaus principles. Be skeptical. We see these buildings that are alleging to be Passivhaus buildings falling short of owner expectations, so buyer beware. If the building is not certified by one of these certifiers, your risk of not meeting your targets, your risk of producing a gap in performance can go up significantly. You may now be saying to yourself, okay, well, that's all well and good, but how do we actually do it? All right, it's time to dive in. As we've noted, we need to re-engage the passive building elements, the architecture, the structure itself, and empower it to do the heavy lifting. The Passivhaus Institute provides an integrated methodology that organizes the work and helps keep you on the path. The methodology focuses initially on the enclosure, then ventilation, and lastly on active heating and cooling. We'll look at the role of insulation and thermal bridge-free connections. A thermal bridge is where there's a break in the insulation and heat can more easily escape, like a cold metal window frame in winter. We'll look at air tightness, high-performance windows and doors with solar protection, and high-efficiency heat recovery ventilation. These are the key ingredients or principles. These key areas and more are all entered into the Passivhaus Planning Package or PHPP energy model. The PHPP is an Excel-based tool which allows the designer to simulate the behavior of the building both during peak times, winter and summer, and over the entire year. This flexible, easy-to-use model allows for quick iteration and design alternate evaluation. The PHPP and all other simulations should be implemented not just as compliance tools, demonstrating that the building meets the standard, but as design tools, which allow the team to iterate and evaluate a host of ideas and options, real-world assumptions, and possible future scenarios. This doesn't mean that the PHPP controls the design, but rather that it helps to inform the design with performance data throughout the process. This is the essence of data-driven design, of good design. With that, let's take a closer look at the basic principles, starting with the first, right-sized continuous insulation. Generally, this means more insulation than normal, but not always. The idea is that you want to insulate to where you don't just shiver less, but you are actually comfortable. Typical buildings are a lot like an underdressed teenager wearing nothing but a hoodie in midwinter. They'll survive, but do we really want to live like that? You know that if you wear the right layers and a good parka and a hat and so on, you can not just get by in the cold, but actually be warm and comfortable. Our passive house is the same way. Or think of it as temperature-rated sleeping bags, all surrounding the conditioned space. Principle number 2 then extends this thinking to make sure we don't have breaks in the insulation. In construction, thermal bridges may not seem important in isolation, but they can completely undermine the building's performance. If we think of a thermal bridge as a cut, your project can easily die from 1,000 thermal bridge cuts if you're not very careful. Examples of thermal bridges abound. The thermal image on the lower right shows the common balcony connection turning a building into a radiator to the world. 1,000 cuts. The colder interior surfaces can cause condensation, as we see on the window frame at the upper right, and mold on the left. To overcome them, typically we overheat, treating the symptom with brute force. With Passive House, we avoid the problem in the first place. Thermal bridges typically occur at junctures where the floor meets the wall or wall meets the roof, or at window frames meeting walls or balcony connections. The energy losses causes thermal discomfort and condensation and moisture damages. Traditional energy models don't account for thermal bridges and is a big contributor to the oversizing of mechanical systems, just to be safe. In Passive House, we look carefully at all these connections and junctures, work through the construction details, and eliminate the thermal bridges entirely or minimize and calculate them. We include them in our PHPP energy model. This results in increased predictability and produces lower risk construction. Principle number 3 is an airtight enclosure. And while when the subject comes up, people might reflexively touch their necks and worry about poor indoor air quality and perhaps succumb to nightmarish imaginings of not being able to open windows, we need to set the record straight from the start. 2 concepts are in play: quality indoor air and our freedom. And so we need to flip the common and wrong-headed thinking on both. First, let's address quality. The fundamental idea at work here is that it is very difficult to control the quality of something if you don't actually first have control of the thing itself. If the enclosure is leaky, the polluted outdoor air is moving willy-nilly through the building. Consequently, the only way to have any sense of control is to overcome it with power, never sure if this space or that space is properly ventilated. Like thermal bridges, we're treating the symptoms with more brute force. But in an airtight environment, the air is under control, and we can very efficiently and confidently maintain its quality. Airtightness sets the table for healthy indoor environments. But you say, that's all well and good, but the Passive House police won't let me open the windows. It's fascism. Quite the opposite. Of course, there are no Passive House police. You can open the windows. But let's think about it for a second. You often open the windows when the indoor environment feels unhealthy and uncomfortable, and you feel the need for the fresh air. It's not a want, it's a need. But in a Passive House, you have clean, fresh air, whether the window is open or closed. You don't need to open the window. You open a window because you choose to. You want to do it. It's a lovely day. Open the window and let the breeze blow through. How nice. Passive House is actually giving you the freedom to choose. So, with that set straight, let's take a moment to talk a bit more about why airtightness is so important. And it's because it profoundly affects so many fundamental aspects of building performance. We've just spoken about it supporting indoor air quality. What about comfort? Well, it eliminates those annoying drafts we need to overcome with enlarged mechanical systems, more brute force treating symptoms. Airtightness also protects the enclosure from moisture damages. Airtightness radically reduces heat loss. If we take two buildings, both well insulated equally, but one is leaky and the other passive house airtight, the difference in heat loss could easily exceed a magnitude of 5 times. 5 times the difference. They become totally different buildings based on airtightness alone. And so, if in your energy calculations, design, and construction, you can confidently provide greater airtightness, don't just hit passive house airtightness, go hit twice the airtightness. The first passive house in 1990 did. And you can eliminate lots of insulation. Teams that are proficient in providing airtightness can achieve huge enclosure cost optimization and savings. And in hot, humid conditions, airtightness keeps the humidity out and reduces the demand for dehumidification, allowing the cooling system to be sized mostly for cooling, as it should be. For all these reasons, the truth is that buildings can never be too airtight, and Passive House takes full advantage of this truth. Number 4, high-performance windows and doors with solar protection. The flip here, of course, as we spoke in the beginning, is to rid ourselves of the unfortunate association people make with past passive solar buildings. And we must always be on guard to avoid overglazing and the accompanying overheating. The passive solar buildings of the 1970s and onward were overglazed, out of balance, and often uncomfortable. If you recall, the precursors to Passive House in the 1970s were not passive solar buildings. They tended to be super insulated buildings that balanced daylighting needs and solar heat gains and losses. Passive house buildings don't have tiny windows either. We're not building caves. Expansive views abound. We will utilize passive solar heat gains, but we are being very conscious about the energy balance, about solar protection and the consequences. Restraint may be a good word for what we're showing off. A key concept here is that the windows and doors act not simply as a provider of views and daylight, but they are a critical component in our continuous insulation and airtightness. The windows themselves are often triple pane and truly thermally broken and airtight with 3 layers of gasketing. And the window connections to the surrounding construction and airtight and insulation control layers must be airtight and insulated. Thermal bridge free connections, of course. This all gets you deep into the construction details. Passive house windows can come in any type: metal, wood, metal clad, wood, PVC, and fiberglass. There are dozens of suppliers to the US market today, and there are several North American manufacturers producing Passive House certified units. Be sure to check out the certified component database on the PHI website, passivhaus.com. Window quality is a primary driver of comfort, and while there are a myriad of factors, the fundamental idea here is that our typical windows result in significant temperature asymmetry. In winter, the window is colder than the other surfaces and you feel it. It causes convective currents, and this needs to be overcome with perimeter mechanical systems. With Passive House, the windows are of a quality that their temperature is close enough to avoid discomfort and avoid the need for mechanical systems to compensate. Because the windows are such a critical component and their performance cannot be compromised, we recommend the Passive House Institute certified windows are utilized. And while windows provide our views and daylight and, yes, useful passive heat gains, improperly designed windows can cause significant overheating, causing discomfort and additional air conditioning requirements. And we know that overheating is a common problem in conventional buildings across industry today. The best approach to avoiding overheating is to carefully provide proper shading. Shading can be provided by how the window sits in the wall, by an architectural element, or landscaping. Needed shading can be achieved with interior blinds as well, but exterior shading is the most effective. Shading cannot be an afterthought. It cannot be optional. Number 5, high-efficiency heat recovery ventilation. Let's recall back to the Platonic definition of Passive House. A primary goal was to ensure effective hygienic ventilation. Today, in coping with the COVID-19 pandemic, hygienic ventilation is a hot topic. Add to that the inescapable forest fire smoke, and the long history of poor health outcomes for marginalized communities on the fence line of industrial production, and of course, hygienic ventilation should be a foundational goal. And remember also that what is going to set us up here for success is the airtight enclosure. There is no pollution entering willy-nilly as happens in typical construction. We have control of the interior air. Now, typical buildings have ventilation systems, just bad ones, often providing only intermittent exhaust from bathrooms and kitchens, and don't ensure good ventilation everywhere. And in commercial buildings often includes a lot of recirculated air. In passive house buildings, we supply 100% fresh air to every served space: bedrooms, living rooms, offices, classrooms, and 100% exhaust from every service area: the bathrooms, kitchens, utility areas, hallways, all operating continuously 24/7. The systems are laid out to ensure that all spaces have robust ventilation. Again, zero recirculation. Now, such a system of 100% air changes would normally be prohibitively expensive to operate because typically you need to heat or cool that fresh air to maintain comfortable interior conditions. But this gives us the passive in ventilation because there is a passive heat exchange element, a core, located with the fan unit that allows the heat and energy from the outgoing airstream to move to the incoming airstream. And today, the efficiency of this passive exchange can exceed 90%. This means that on a cold winter day, the fresh air supply, without any added heat, enters the room within just a few degrees of the room temperature, ensuring occupant comfort. And Passivhaus Institute certified ventilation units ensure that you get the performance and cost savings you expect. In looking at the energy balance of the building and the building design, we are also going to look at things that provide internal passive heat gains as well: the people, appliances, and equipment, the lighting and mechanical systems, because they can contribute significantly to providing the heat needed in winter. It all goes into the PHPP energy model. So at this point in moving through the building design, the metaphorical fulcrum is pushed as far as it can go. The architecture and other passive elements are doing the heavy lifting, but still, there will likely be a need for active heating, cooling, and maybe even dehumidification, depending on where you are. It's important to remember that this is about optimization, not magic tricks. So what we see is the ability to meet the occupant needs with about a 75% reduction in mechanical equipment sizing and up to a 90% reduction in usage. We can pull the distribution to the core of the building, and because the loads are so low, electrifying everything is much more economical. We can get rid of hydronic heating if we like and provide heating and cooling from a single heat pump system. The only trick here is perhaps getting the mechanical engineer to agree with the plan, because at first glance, they might see a building that will fail. I mean, how could it not with such a small mechanical system? It can take a few meetings, but with careful explanations, even engineers who have seen initially energetically opposed can become ardent supporters. We need all you engineers out there on board. We can't do this without you. And then there are smart systems. Passivhaus isn't opposed to incorporating smart systems and technology. Even the first passive house had a CO2 detector to help control proper ventilation. But the smart systems should enhance high performance. They should not be used to compensate for poor performance. So let's make the architecture do the work. Let's incorporate only the most efficient equipment, and let's add smart systems as we like, but always with an eye toward greater simplicity. Let's simplify, simplify, and simplify. Our resilience depends on it. So this methodology we've described has global applicability, is being applied all over the world, and the basic principles have local solutions. We are grappling with global crises, and we can all work together around the world learning from each other to address them. Today, I want to end here with another look around at a great variety of passive house buildings underway. Some more examples. In China, passive house is exploding. Here's an example of a guest hotel for a company south of Beijing. In the UK, in Exeter, they're building a municipal leisure center with big indoor swimming pools. Today in Exeter, the city builds everything to Passivhaus standards: affordable housing, their schools, administrative buildings, and now this leisure center. And the Congo is not a place you'd necessarily first expect to find a Passivhaus building, but Belgium could be. So when the Belgian government planned their new embassy in Kinshasa, they made it a Passivhaus. Grimshaw Architects has just completed this stunning academic building at Monash University in Melbourne. Sophisticated, affordable housing in Philadelphia that is net zero from on-site renewables. And here is a single-family scale building, although it's a retreat for musicians, truth be told, in southern Vermont. It's beautiful in setting and balance. It shows that a modest building in a tough climate can be filled with light, have great views, and serious architectural expression. We can have it all. We just need to imagine it and work for it. So as the world heads toward climate tipping points and we plainly see the interconnections of these crises, let's have the imagination and determination to seize the inherent power of building and really leverage it so that we can confidently deliver better health outcomes, support greater equity, and deliver climate action proportionate to the emergency at hand. We see the push to zero carbon emissions on the horizon across the board and coming at us fast. Let's not wait another day, but instead, let's set ourselves up to meet that world by building Passivhaus buildings now. So are you thinking differently? Are you ready to act? Let's get to it. I hope to see you at future NAPHN Passivhaus trainings and events. Thank you for your time, and if you have a few more minutes, there's bonus content just ahead. Be well.
First Passivhaus project, I was so fearful that I didn't tell anybody that it was going to be a certified Passivhaus building. And sometimes that can help, particularly working in local government, because normally if I asked to build a Passivhaus building, I probably would have been told no, so I didn't tell anyone. So I was pretty fearful that the concept wouldn't work. But believe me, once we finished our first development was very modest. It was 3 flats. It became certified, and for the last 12 years, we haven't looked back. I cannot imagine building anything that isn't a certified Passivhaus building. It would just be balmy.
And then the third, would the people recognize the benefits of Passivhaus, and would they rent it from us? So we definitely tailored our marketing with our marketing and our leasing team that really focused on the health and the quiet benefits, rather than nerding out with all the science that people rent in New York City through emotion. It's very emotional. It's not because a number is better than another building's number. That is meaningless, and you might as well just go to sleep. So for us, our marketing that really helped us, and we leased insanely fast.
Bridging the Gap Development, our mission is to bridge gaps of opportunity and also to bridge gaps in development. So we're always looking for ways to innovate. I'm naturally an innovator, looking for ways to disrupt and to really push the market to the next level. So when I started to learn about Passivhaus and see some other projects in other cities, it really intrigued me as an opportunity to bring that here and really disrupt and innovate here in our region. Really that's what kind of got me going down that path, looking more into it, researching, and ultimately decided to embark upon the Passivhaus journey.
This part of the conversation with Kathleen.
Yeah, so I think for us working with, the MIT field people and understanding more about this idea of healthy buildings and greater productivity, that was really intriguing for us, because as real estate people, we tend to think about space. It became very clear that what our tenants and clients were thinking about is really human beings, and that workers account for a lot more dollars than dollars per square foot. Always intrigued me that people, tenants particularly, didn't spend a little bit more time kind of worrying about OpEx expenses. That always seems to come secondary. But when you really look at where companies spend money, yes, they spend it on dollars per square foot, but they really spend it on their HR. So once we came to terms with that's what the world that we're trying to attract is interested in, then the idea of greater indoor air quality, healthier buildings, that all played to better workers, more productive workers, retaining your workforce, and producing a product that would do all these things. Passivhaus does all of that. So that really cinched the deal for us. It allowed us to be that real estate decision for our corporate clients.
We've been investing in Passivhaus now for over a decade, so we don't really consider any other form of building delivery. And that's because Passivhaus has proved itself to offer real value for money and to be really a sound investment proposition.
I began to see the wave of different organizations and funding streams starting to push in this direction, starting to incentivize with additional points, additional tax subsidies or subsidies in general. So that was definitely a driver, in addition to looking at, the market being a market differentiator, cost on the back end, not only from an operation side for the owner, but also for residents. So everything combined. But I think once I started to see a wave, I wanted to get ahead of it. And this was an opportunity to do that.
So our ultimate approval authority for our project is the Pentagon. And we haven't told them yet about our project. So I'm joking a bit.
We're all now
Your
read
secret's
in.
safe.
Yeah,
Yes.
we're all read in now, so we're good.
But yeah, talk about large bureaucracies and navigating bureaucratic approvals. It's the ultimate organization. So, but we do have local buy-in from the local base commander. We have buy-in from my company, and we also will be, since it's again just a small pilot, we're going to be falling within our approved budget thresholds by the Pentagon. But I do anticipate a successful pilot and then being able to celebrate it with the Army and the Pentagon. And the hope is that they will encourage all military housing projects to, adopt the Passivhaus Standard.
Now, will you?
For me, the big thing here is I'm focusing on trying to improve our efficiencies in every aspect of our business, whether that be our processes, whether that be, the accessibility to our stores, whether that be our bricks and mortar. Well, to summarize this project here, after I built this, my appraisals with comparative type analysis for other dealers out there, I'm not spending more. I'm really building something that did take a little bit longer, yes, but I think I could dramatically improve next time. And now I'm just the guy here who has a 1, marketable advantage, 2, cost savings advantage, and 3, I've got, from an employer standpoint, a quiet, well ventilated, ease of livability building that my competitors don't have. So I'm sitting here thinking, okay, it felt like I was spending a whole ton of a lot of money more, but my other question is, what are these other guys wasting their money on if they spent the same amount I did?
It's a great question. But first, I just want to say that I completely agree with all of my colleagues on this call. And I just wanted to point one thing out that I think is very interesting, because we're talking about stakeholders. We're talking about the people doing and building Passivhaus. We're talking about the governments. But I think what's going to shift, and you're going to see a shift with actual people and their view on Passivhaus. So I heard a great statistic that was between 2004 and 2014, average utility costs for a household in the US went up 39%, but income growth went up 0.9%. So with all of the eyes opened to people facing injustice and all of the things going on in the various political movements that we see outside of our windows every day, I think you're going to see a real shift to how energy is involved in this. And I couldn't agree more with Emma's comments on the triple bottom line approach. And I think you're going to see residents and users seeing that more. And that's pretty much, I mean, Hudson Company we think of these things in a triple bottom line lens as well. So it's not just we have affordable and we have market rate. And so like Ryan said, we are pretty much in the same boat of needing to, we're ticking the boxes and responding to RFPs and meeting Passivhaus standards, but not just because we want to tick the box, but because those are our standards internally. But we're also trying to make those cases to the government stakeholders that are financing our projects that this is just really the way to go. Passivhaus is the way to go.
A couple of tenants in the marketplace actually said, well, we don't know what Passivhaus is. Many of our commercial brokers didn't understand Passivhaus. And like Nicole mentioned, it was, well, that's a house. This is and we're not sure we want to be a guinea pig to this new technology. And really having to educate the real estate community about Passivhaus was a fear I hadn't anticipated, but we started to realize, wow, we're in this and we're going to need to spend some extra time and some extra resources explaining to our own community what Passivhaus is all about, and that the technologies are not new. Triple glazing has been around for a long time. Thermal breaks are something you should practice anyway. When you break it down, there's nothing that technical about Passivhaus. It's the way you put it together and the way you, babysit it during the construction project, which is the other piece that's really exciting for someone who deals with curtain walls. You're not going to find out you have a leak at the end of the project because you're testing as you go. So those are the side benefits of Passivhaus. But anyway, the education piece kind of caught me by surprise.
Yeah.
That what we were doing was everybody that comes onto the job site gets a briefing, and we try and educate them on what they're doing here, right? In the totality, right? Because we found once somebody understands, how they fit into that whole picture, they're just more inclined to be aware and do a better job. So in British Columbia here, we have what's called British Columbia Institute of Technology. So there is a training program for workers, right? So you now can get a certificate for Passivhaus building, right? And typically the framers, and envelope people will do that. But just
tradesman classes aren't required for Passivhaus, and going to the buy-in by the contractors and the team, I got that feeling, Emma said it's a gut feeling. If they didn't buy in from the initial conversation about quality and about the energy efficiency, they just never got on the job. So, for us, that buy-in was important top down. So it started with the owners and started going to the foremen and then to the actual workers. And everyone along those lines took the tradesman classes. And so it really was easy to monitor.
I think I just want to echo everyone else here and just say that, you can get into analysis paralysis all you want. But when thinking about Passivhaus, it's important to think about the cost of not doing it at this point. Both monetarily and beyond that. And I think that once you start thinking about all of the benefits globally, it becomes a fairly straightforward choice.
Just do it.
Just jump in.
Yeah, because what you're doing, and all of it, everyone's touched upon it today, is you're creating premium buildings, exemplar buildings that transform people's lives. And not just the residents or those people who are working or occupying those Passivhaus spaces, but you're transforming the whole teams that deliver those projects. Because when you're building a quality building, actually all our professionals, all our contractors, subcontractors, that's all they ever yearn for, to produce buildings that they're proud of. And so what starts as a performance standard turns into something that transforms people's lives, and start those ripples. And, those ripples are rippling outwards. And the more that we can encourage other people just to try it, just do it.
Yeah.
they will not go back to a different way of building.